Imagine a spinning radar dish or the arm of a clock sweeping around a dial. Today we'll see how one simple circle gives the sine and cosine of any angle you'll ever meet. By the end you'll read coordinates straight off the unit circle and predict trig values without a calculator. The unit circle is just a circle with radius 1 centered at the origin of a graph. Because the radius equals 1, every point on the circle is exactly 1 unit from the center. For any angle theta measured from the positive x-axis, the point where the ray hits the circle has coordinates cosine theta, sine theta. The x-coordinate is cosine theta and the y-coordinate is sine theta, always in that order. Quadrant 1 holds angles from 0 to 90 degrees, quadrant 2 from 90 to 180, and so on. In the first quadrant both cosine and sine are positive. In the second quadrant cosine is negative while sine stays positive. Reference angles are the acute angle each ray makes with the x-axis, letting us reuse the same numbers in every quadrant. 0 degrees lands at the point 1, 0, so cosine 0 equals 1 and sine 0 equals 0. 90 degrees points straight up to 0, 1, giving cosine 90 equals 0 and sine 90 equals 1. For 45 degrees we draw a square inside the circle. The diagonal cuts the circle at root 2 over 2, root 2 over 2. So cosine 45 equals sine 45 equals root 2 over 2. About 0.707. Let's convert 150 degrees. The reference angle is 180 minus 150. So 30 degrees. 150 sits in quadrant 2 where cosine is negative and sine is positive. Using the 30 degree values with signs adjusted, cosine 150 equals negative root 3 over 2 and sine 150 equals 1/2. The unit circle packs every sine and cosine value into one neat picture. Keep its key points in mind and you'll estimate trig functions for any angle in under a second. Generate your own educational videos for free at eduvids.vercel.app.